All right, guys, so before we get started, are there any questions over any of the assignments thus far? Any questions over any of the homework assignments? What we're looking at today, the first thing we're looking at is adding and subtracting matrices. To add or subtract two matrices with the same dimensions, add or subtract the corresponding elements. So you don't have to write this down, but this is kind of the overall look at it. Sum or difference of two matrices with different dimensions is undefined. It is not possible. So let's actually see what this looks like. So we're going to perform the indicated operation. So if we look at these two here, the first matrice is a 2 by 2. The second matrice is a 2 by 2. So the dimensions are the same. So we can add these. So corresponding elements are going to be added or subtracted. Since we're adding, we're going to take 2 and add it to 1. Those are corresponding elements. And we have -1 plus 2. That takes care of the first row. Our second row, we would have 3 plus 4. And lastly, 0 plus -2. Questions on this so far? So now we really just need to add. So 2 plus 1 is 3. -1 plus 2 is 1. 3 plus 4, 7. And 0 plus -2. -2. That's it. Questions on adding these two matrices together? We're ready for the next one. So this time we want to subtract them. Our first matrice is a 3 by 2. 3 by 2, 3 rows, 2 columns. Second one is a 3 by 2. Since the dimensions are the same, it means we can subtract these two. And to subtract them, we're going to subtract the corresponding elements. So we'd have 2 minus -1. Then we would have -3 minus 2. Then we would have 5 minus 7. 4 minus 8. -2 minus -5. And lastly, 8 minus 6. If their dimensions are the same, we add or subtract the corresponding elements depending on the operation we're doing. Here we're subtracting, the previous one we added. Questions on this here? Well, the last thing we need to do is actually simplify this. 2 minus -1. Negative and negative make a plus, so 2 plus 1 is 3. -3 minus 2 would be -5. 5 minus 7 is -2. 4 minus 8, -4. -2 minus -5, well, negative and negative make a plus, so -2 plus 5 is 3. -2 plus 5. Yep, negative. If it had been -2 minus 5, yes, indeed, it would be -7. And lastly, 8 minus 6. Adding and subtracting matrices is really nice. We've just matched the elements up, add or subtract, and we're good to go, yes? All right. I think we got the hang of this. So when we look at C, we're going to be doing -8 plus 6, yes? Then we have 1 plus -1 and 3 plus they're different dimensions because the first one is a 2 by 3. The second one is a 2 by... If the dimensions are not the same, this is not possible. Undefined. We cannot have it. So it's not possible, undefined. Funny enough, this would not be a no solution, because we would say something's no solution if we're solving. We're not actually solving for anything, we're simplifying. We're performing an operation, so it's just not possible to perform the operation. Because, and I jump into this and do this intentionally this way, because as we see, -8 and 6 do match up, we're good there. -1 and 1 do match up, we can add those there. But because 3 in the first one doesn't have anything it matches up with a corresponding element in the second, there's nothing to add it to. It feels like we can just go say here 0 and 0 and be fine. But as soon as I add those zeros, I now have a different matrix than we started with. So there's no way to combine them. There's no way to add them. It is not possible. 2 by 2, 2 by 2. So we can add these, yes? We'd be adding what? -1 plus 6. 7 plus -4. Then we have 5 plus -8. And lastly, 3 plus 2. -1 plus 6 is 5. 7 plus -4 is 3. 5 plus -8. -3. And lastly, 3 plus 2 is 5. Questions on this here? Now, if we really wanted to, we could plug this into the graphing calculator. And to do that, we'd have to go second matrix, over to edit, and we would put the first one in. It is a 2 by 2, so we'd say -1, 7, 5, 3. Second quit, second matrix. Over to edit, we'd go down to B, which is also a 2 by 2. 6, -4, -8, 2. Second quit. Because we'd have to put both matrices in. Since we're dealing with 2, we have to put one in as A, one in as B. If we had 3, we'd put them in as A, B, C. Now for this one here, we wanted to take matrix A and add to it matrix B, which is the exact same thing we got, yes? But honestly, it takes as much time, if not more time, to plug it into the calculator than it did to just do it by hand. We could have just grabbed the 30XS, our yellow calculator, and just added and subtracted each element and got there faster than using the graphing calculator. Let's look at the next one. 2 by 1 minus a 2 by 1. Two minus -3. 5 minus 0. 2 minus -3 is 5. 5 minus 0 is 5, so 5, 5. Yep. Because with addition and subtraction, the dimensions have to be the same, and the ones we finish with is going to be the same. Since they were both 2 by 1s, our answer has to be a 2 by 1. We cannot switch it to a 1 by 2. Those are not the same matrices. Questions on any of this here? Not possible. We cannot add a 2 by 1 with a, or subtract a 2 by 1 and a 1 by 2. Have to be the same dimensions. We ready for scalars? Scalar multiplication. When we scale something, we're going to multiply every element in the matrix by said scalar. That's all that says. So we look at something like this here, 2 times this matrix. we're going to multiply every element in the matrix by 2. So we'd have 2 times 3, 2 times negative 2, 2 times 1, 2 times 5, 2 times 2, and 2 times 0. We just multiply everything by that amount. Now, the scalar does not have to be an integer. It can be fractional. It can be anything we want. Then we just need to multiply. 2 times 3 is 6. 2 times negative 2 is negative 4. 2 times 1 is 2. 2 times 5 is 10. 2 times 2 is 4. And 2 times 0 is 0. Again, the graphing calculator can do these. We just have to put the matrix E in, and then when we type it out, we'll say 2 matrix EA, 2 times matrix EA. If a number is put in front of the matrix E in the calculator, it's going to assume its product. It's going to be multiplied. So if I go 2 matrix A, it will take that matrix and multiply it by 2. We do get a different matrix E than what we just got because I did not actually put that matrix E into the calculator. Questions on scalars? I think we feel comfortable with scalars. I don't think we need to do a ton more than that. So let's actually combine scalar multiplication and addition, subtraction. When we have the two together, we do scalar multiplication first and then add or subtract the result. Now we do need to make sure that we can actually add or subtract because scalar multiplication does not change the dimensions. We still have a 2 by 2 and a 2 by 2, so we can add them regardless. So the first thing we'll want to do is the scalar product. So the first matrix, we're going to multiply each element in there by negative 3. Now because it's only in front of the first matrix, we are only multiplying it by it. We're not going to multiply the negative 3 by the second matrix because it's not being applied to it, only being applied to the first one. Two scalars, yes. We'll do that here in a minute. We'll have to fix one of them to do it, but we can do it. Questions on how we got the first matrix to negative 15, 0, 6, negative 12? We good to get here? And we just add the two together. We agree? No, I agree. It should be negative 16. Do you know why? What did I do? I dropped a negative. It should have been negative 15 plus negative 1, which is negative 16. Mm-hmm. Questions on this here? I would say calculator, using the graphing calculator starts becoming a little faster if we have multiple scalar products and addition, subtraction all being done at the same time. Then it starts becoming a little bit quicker to do it in the calculator, especially if they're using the same three matrices over and over and over again. Questions on how we did this? Now, do we have to actually write out the times negative 7 on each one and then multiply? No. Because if we wanted to, we know we're going to multiply everything by negative 7, yes? So negative 7 times 2 is negative 14, yes? Negative 7 times 3 is negative 21. Negative 7 times negative 2 would be 14. Negative 7 times negative 7 is positive 49. Negative 7 times 4, negative 28. Negative 7 times positive 7, negative 49. Negative 7 times negative 2 is 14. Negative 7 times positive 5 is negative 35. And lastly, negative 7 times negative 6 is 42. If you can do that and just go multiplying, do that. If writing it out with the negative 7 times 2, writing it all the way out with that product and then multiplying helps, do that. Okay? Because it's what's going to help you more is what you need to write down. Questions on number 5. Now, before you guys start working on number 6, I want to change it slightly. There we go. So, what we're going to change it to is minus 3. I want to put a 3 in there. Specifically, one, we're going to actually see where we have 2 scalars being applied, and 2, we have a negative in front of that second scalar. Now, the first scalar kind of makes sense. I'm going to write it out this time. We have 4 times 3, 4 times 5, 4 times 4, 4 times 2, 4 times 0, and 4 times negative 2. That we're fine with. We just multiply through by the 4, we multiply by that number. The second matricing, are we going to multiply by 3 or negative 3? I would say yes. Both. It's up to you what we do. You can multiply through by 3 or negative 3. Either one will work. We just have to pay attention to the sign in the middle. Because if I choose to multiply through by 3, 3 times 9, 3 times 7, the sign in the middle stays minus. We're just taking the 3. Because if we multiply by positive 3, we keep the subtraction in the middle. If we'd have multiplied by negative 3, if we'd have said all of these here were minus, the sign in the middle would become positive. So we either multiply by 3 and then subtract the 2, or we multiply by negative 3 and then add. It gives us the same result either way. Do y'all want to multiply by 3 or negative 3? 3. Roll that back. So now we just need to do our scalar multiplication. 4 times 3 is 12. 4 times 5 is 20. 4 times 4 is 16. 4 times 2 is 8. 4 times 0 is 0. 4 times negative 2 is negative 8. Minus 3 times 9 is 27. 3 times 7 is 21. 3 times negative 6 is negative 18. 3 times 5 is 15. 3 times 2 is 6. And 3 times negative 3 would be negative 9. Now, the last thing we need to do is subtract these two. $12 minus 27, 20 minus 21, 16 minus negative 18, 8 minus 15, 0 minus 6, and negative 8 minus negative 9. 12 minus negative 27 would be negative 15. 20 minus 21, negative 1. 16 minus negative 18, negative and negative make a positive. So we're saying plus there, which is going to be 34. 8 minus 15 would be negative 7. 0 minus 6 is negative 6. Negative 8 minus negative 9. Again, negative and negative make positive. Negative 8 plus 9 is 1. We agree on this here. We ready for what's next? That's it. 4 through 8, 9 through 21, odd. Seven and 8 is again error detection. Error detection. There's something wrong with those. So you need to fix it. Tell us, or actually see what the actual difference or sum is. Add or subtract, and then say in words what they did wrong, because they messed up, I think, both of them. Well, they should have. 9 through 21, odd. Just perform the operation. Yep, so 9, 11, 13, 15, 17, 19, 21. That's it. 1.7 is the last part of chapter 1. We are finished with chapter 1, which means Monday is a makeup day. You will have the entire class period to work on your missing assignments. Tuesday is going to be a review day. I will give you the review sheet. You will have the whole class period to work on it. Wednesday, we will go over the review. Thursday is part 1. Friday is part 2. Yes. We'll work it out.